Welcome to Easy to Learn Technical Skills channel. Today I am going to discuss the concept of queue. So what is called as a queue? Queue is a linear data structure. Queue having the principle first in first out. So there are so many real-time examples are there like ATM queue as well as the verification queue. So the queue having the principles of first in first out. There are two ends are there. The one is called as front as well as the rear. So the insertion will be happen at the rear end and the deletion will be happen at the front end. So this is the basic qualities of a queue. Now we are going to discuss about the implementation of queue. The queue can be implemented in two ways. One is called as static implementation like array implementation. Second one, dynamic implementation is called as linked list implementation. So this is called a static and this is a dynamic. So dynamically we can allocate the memory space in linked list implementation, and the static implementation is a fixed implementation. The size is fixed. And in this video I am going to focus on the static implementation like array implementation of queue. So here I am going to define the queue size is called as 5, and initially the front is -1 and the rear is -1. Why? Because there is no queue as of now. And now I am going to form a queue. So once we define the queue, we have to define the functions. There are two functions are there. The enqueue operation will be performed at the rear end and the dequeue operation will be performed at front end. There are two operations are there. So now I am going to perform on the enqueue operation. Enqueue operation in the sense we are going to do the insertion of the queue. The insertion will be takes place at the rear end. Now I am going to check the queue having some space or not. So if the queue having the space, we can able to do the insertion operation, just assuming that the queue is as of now empty. So this is a way we have to read the element for the queue. So scanf ampersand value. So this value will be inserted on the queue. So now I am going to check one condition. If rear greater than size -1. Size is called as a 5. What is called as a rear? The rear is -1. So rear is -1 is lesser than size -1 is called as a 4. If the conditions become true, we can do the insertion operation. Queue of plus rear is equal to value. So the value whatever we are giving, that will be stored in the queue of rear position. So before that I am going to increment the rear position. Initially the rear position is -1. After incrementing this plus rear, it will become 0. -1 plus 1 is equal to 0. Now the value will be stored on the 0th index of queue. I hope you know the concept of array. Array means collection of similar data items and the index start from 0 to n-1. Here the total size is 4. Index starts with 0. So now likewise in this queue of array, we are going to store the array elements. The index position starts with 0. So here the 0th index I am going to place the value 10. Okay. Initially the front and rear pointing to -1 because of the assignment front equal to -1, rear equal to -1. So front equal to -1 and the rear is equal to -1. So after incrementing this statement, so after executing this statement, the rear position will be incremented. So what is called as the rear position? Initially -1 and now it is become the 0. So after incrementing this front position and the rear position, we are going to store the value in the position of rear. And now this is called as a front as well as this is called as a rear, because we are going to store the position of 0th index. Now the value will be stored on the 0th index. If I am going to suppose to store the value 10, and once we store the value, we have to increment the index positions. So after the queue of rear is equal to value statement, we have to write one statement. If front equal to -1, now we have to assign that front equal to 0. Here the statement says that if front is equal to -1, once we read the one value and the value will be stored in the 0th index, and now the front position is created as well as the rear position also created. So likewise we have to assign the first value. So now I am going to read the value 20. Just imagine that the 20 will be given through the help of scanf statement. So once we read the scanf statement, you have to check with the index. So rear is initially pointing to the 0th index because just now we increased one position and the rear position is pointing to the 0th index. And now we are going to check the rear less than size -1. So 0 less than 4 conditions become true. Once the conditions are true, whatever the value we have, that will be stored in the plus rear. What is called as plus rear? The initially the plus rear pointing to the 0th index. Now it is become the first index because we have the statement like that. So 0 plus 1. So the answer is called as 1. So now we have to increasing the rear position, and now we have to store the value 20 in the position of 0th first index, and now we have to increasing the rear position to the first index, and this is called as a rear, and the value 20 will be stored here. After that, we have to check this statement also. If friend is equal to minus 1. No. Why? Because the friend is already incremented to 0th index. So there is no chance of executing this if condition. Again, it will comes to the Enqueue. So next I am going to read the value like 30. So what is called as the value? The value 30, and you have to check with the condition. So here we have to write down the current rear position is 1. So 1 less than 4 conditions become true. So once the condition is true, then come into the statement Q of plus plus rear equal to value. The 30 value will be stored in the position of plus plus rear. So what is called as plus plus rear? The rear position is already pointing to 1. So 1 plus 1 is equal to 2. The second index position, I am going to store the value of 30. And you have to check meanwhile if your friend is equal to minus 1. So these conditions become fail. Now we have to store the value of rear position, and now this is called as the rear position, and you have to increment at the index also and store the value 30. Now we are going to have one more value. Just imagine that I am going to give the value like 40. So what will happen? You have to read the value through the help of scanf statement. Then rear less than size minus 1. So what is called as the rear now? The rear is pointing to the second index, second less than 4. So now the conditions are true, then come into the if condition. Here Q of plus plus rear equal to value. So whatever the value you have, that will be stored in the plus plus rear position. So what is called as a plus plus rear? So we have the rear position, already we knows that the rear position pointing to second index plus 1, so is equal to 3. So we are going to store the Q of 3 index as a value now. The value called as 40. So you have to increment the rear position before we are going to store the value. So now this is called as rear, and the value called as and the index is called as 3, and the value is called as 40. And now suppose if you are going to increment the one more index as well as if you are going to store one more value, you can, because we have space to insert. Just imagine that the value called as a 50. If I am going to store the 50, you have to check with the if condition. If the index less than size minus 1 or not. What is the index position? Index is called as a 3. What is called as the index? Index is called as a 3. 3 less than 4. Conditions become true. If the conditions are true, we can able to store this value in the rear position. So Q of plus plus rear is equal to value. What is called as the index now? The index position is 3. So 3 plus 1, which means the rear plus 1. So the answer is called as a 4. Conditions are satisfied. Now we are going to store the value in the fourth index. And now suppose if you are going to store one more value, what will happen? Just imagine that 60. Now we have to check with the if condition. So here the index position is currently 4. So 4 less than 4, conditions become false. And now we can able to skip this if statement, else printf Q is overflow. So we can't able to do the insertion operation further. So this is a way we have to do the Enqueue operation. Enqueue means the insertion will be takes place at the rear end. So once we doing the insertion operation, before that we have to check the condition. If the space is available, we can do the insertion operation at the rear end until you reach the queue is full. So once the queue is full, we have to say the statement the queue is overflow, because we can't able to do the insertion operation at the rear end. The queue is overflow. So what is called as a dequeue? Dequeue means the deletion operation. So before we are going to do the deletion operation, we have to check with any elements are there in the queue or not. If the queue having the element, we can do the deletion operation. So first we have to check with the condition if friend is equal to minus 1 or not. So which means that if there is no elements in the queue, initially the queue will be the front and rear pointing to minus 1. Front is equal to minus 1 and rear is equal to minus 1. Suppose if the conditions are true, we can say that printf Q underflow. What is called as underflow? There is no elements on the queue. And if the conditions may fail, what will happen? We can able to delete some elements from the queue. So before we are going to do the deletion operation, we have to print the value. Why? Because once we reduce the index position, we can't able to get the value item from the queue. So before we are going to check that one condition, if the queue having one and only element or not. So one element if I have, we need to write one statement. If front is equal to rear. If the front is equal to rear, we have to remove the data item and make the both indexes minus 1. So front equal to minus 1, rear is equal to minus 1. So in this scenario, if front is equal to rear, we have to set the index position front equal to minus 1 and the rear equal to minus 1 before we are going to assign the value. So once we assign the value like that, then the front and rear pointing to the -1 position, friend equal to -1 and rear equal to -1. Likewise it is pointing. Suppose the queue having some elements other than this first index, just imagine that else what? Else friend equal to friend plus 1. So what is called as the friend? So just assuming that this is called as a friend, and the friend pointing to the 0th index, first index, second index, third index and fourth index. So friend pointing to the 0th index and the rear pointing to the fourth index. And this is the way the queue is as of now present. And before we are going to delete any elements, first you have to check the friend equal to -1 or not. If the friend is not -1, then come to the else part. In this else part, we have to check with the element. The queue element will be printed first. After that, you have to check with the condition if a friend is equal to rear. So here, according to this queue, there is no friend as is equal to rear. So because there is so many elements are there, so this conditions also fail. And now we are going to with the else part. In this else part, we are going to increment the friend position. What is called as a friend index? Friend index is called as 0. 0 plus 1 is equal to 1. Now the friend index going to point to the first index, and now this is called as friend. So now the index position is 1. And now suppose if you are going to delete the next element, what will happen? Again you have to check with if a friend is equal to -1. So the conditions fail because the queue is not under flow. We have some elements to delete. And now we are going to check with the else part. In this else part, first we have to print the elements. So whatever the index position we have to print the elements. Once we have to print the elements, now we have to check with the if friend is equal to rear or not. Now the conditions become fail. Why? Because the queue having some elements other than the friend and rear position. Come to the else part. So now whatever we have the friend position, what is the index position of the friend? The index position of friend is called as 1. So 1 plus 1 is called as 2. Now we are going to assign this to a friend position, and now the incrementation will be happen now. So now this is called as the friend. The friend position moved to the second index, and the value is pointing to 30. If I am going to delete one more element, so if first you have to check with the condition. Whenever we are going to delete any elements on the queue, first you have to check the condition if friend is equal to -1. So here the conditions become fail and come to the else part. So in the else part, whatever the value of the friend, that is called as the 30 will be printed on the screen. And now just check with the condition if friend is equal to rear or not. So what is called as the friend position? 2. 2 is equal to rear is called as 4. Conditions become fail. Then come to the else part. In this else part, we have to the statement friend equal to friend plus 1. So what is called as a friend? Friend is called as a 2. So 2 plus 1 is called as 3. So now the third index is going to assign with the help of friend. And now in the memory space, the friend position will be moved to the next position. And now this element will be removed as well as the index position also removed from the memory. So now I am going to do the deletion operation once again. First, whenever we are going to do the deletion operation, first you have to check with the condition if a friend is equal to -1. If there is no elements on the queue is under flow, but according to the situation, the conditions fail. Come to the else part. In this else part, whatever the elements we have, that will be printed on the screen. So q of friend is equal to pointing the value 40. So 40 will be printed on the screen. Again, you have to check with the condition if both indexes are pointing to -1 or not. No, because the friend position as of now 3 is equal to 4. Conditions become fail. Then come to the else part. In the else part says that friend equal to friend plus 1. So what is called as a friend? Friend is equal to 3. So 3 plus 1 is equal to 4. Now the friend position pointing to the fourth index. And in the memory, we are going to remove this friend position and remove the value also. And now we have to pointing this last position as the friend, and already the rear position also pointing to the last index. Now I am going to delete that element also, and assuming that I am going to delete the element on the queue. So in this first condition, if friend is equal to -1, the conditions become fail. The queue is not under flow. We have some elements, and come to the else part. We have to print the value first. Q of friend is equal to fourth index, and you have to print the value like 50. If friend is equal to rear, yes, of course both indexes are pointing to 4 is equal to 4. Conditions become true. Once the statement is executed, now both indexes are pointing to friend is equal to -1 and rear is equal to -1, and now the statement is executed and the delete element will be deleted on the screen, and now both indexes are pointing to -1. And this is the way we have to do the enqueue and the dequeue operations on the queue. So the queue is following the first in first out principle. There is so many examples are there in the real time, like ATM queue, any file verification queue, or ration queue, or data queue. Wherever we are going to form the queue, we have to follow the same principle only. Once the first person is coming out of the queue, the next person getting the chance to execute the process, and this is the way we have to do the queue operations in the real time. And this is the implementation of static queue, and the future videos I like to explain about the queue implementation using linked list. Thank you for watching my channel. Thank you.